So I am going to give a run through of ways in which one can use concrete and masonry to design healthy and resilient buildings. Really what I'm talking about is sort of people-centric design. So this presentation is a coming together of two bits of recent research that we've been doing within the Concrete Centre. One is on resilience. We've been looking at that for a couple of years now and pulling together the benefits of concrete within resilience. And then more recently, we've been looking, because health and well-being is definitely on the up, isn't it? There seems to be lots of talks about it. People are considering it, especially for offices. These are the three main ways in which health and well-being is being measured from standard point of view. So we've got the well-being trust, that's the well standard, Fitwell, which some people are calling sort of well light, and BREEAM, actually, the health and well-being section within the BRE standard of BREEAM has been around since the 1990s. It was actually very well ahead of the curve. It was brought in for offices with around sick building syndrome. I learned that at an event at the Building Centre. But actually, all of these are related to offices. And there is some now interesting, the thought about offices, and there's a mixed use to a certain extent. And HQM, obviously a BRE standard as well. Are you all aware about the Home Qualities Mark? So it's effectively replaced the Code for Sustainable Homes, or not quite, because it's not mandatory yet. It's still a planning permission thing. But it's interesting to note how many of the points with which you can get points within home quality marks are related to issues to do with health and well-being. So these are very many similar. There's a common theme running through all of these standards: indoor pollutants, daylight, noise, sound, insulation, noise, temperature, ventilation. So many of these aspects, drying spaces, maybe not so, but flood risk, security. Okay, so all of these is recognised that health and well-being is an important part of the quality of a new home, but also from a sustainability point of view, which this is all putting towards it. Now, there was a recent green paper looking specifically into this, so putting together healthy homes and buildings. And I thought there's a quote from there that I thought was a really good summary about why there's quite a lot of interest in this. And it's very dear to me as an architect. I've always been really interested in designing my buildings almost inside out, about what is the experience of the spaces. I know lots of the things to do with health and well-being I think are quite instinctive from an architecture point of view, but sometimes these things get a little bit lost in terms of with cost and programming and the way that things are normally done. So I really welcome this focus towards bringing it back towards people. The recognition, the reason why businesses are picking up on this is a lot to do with the recognition that actually, work productivity and absenteeism, education and attainment. So it's talking about benefits to our health, not just on a national level, because the amount of time that we spend within indoors is actually quite extraordinary, whether it's at the home or in the office. But and so therefore the impact on the health surface, but also then when you bring it down to a business level and then to us fundamentally to ourselves within our own homes. So there's a lot of, so I would say health and well-being within the home environment is slightly behind the curve with regards to offices, because there's a business aspect associated to it. It doesn't mean to say it's any less important. I put this one up. This is a bit of research, a paper that the UK GPC produced a couple of years ago, which was looking into one of the issues to do with health and well-being. And what I particularly liked about this is that they were linking resilience to it, which is the theme of this presentation. But also what I've done is highlighted some of the other issues that I'm going to be talking about today, because of course, lots of the issues to do with resilience and health and well-being, it's not about the choice of material. And I'm coming at this from what is it that the fabric of the building can bring to this argument. And these are the areas that I've particularly highlighted. All of these are equally important. It's just not the remit of how concrete can be fitted within it. Now, this was a great quote. This is from a philosopher, Jaime Casico, that a client of mine found. So resilient is about being able to overcome the unexpected. Sustainability is survival, but the goal of resilience is to thrive. And actually, isn't that what it's all about? We want to be thriving in our homes, thriving in the way that we live, thriving at work. So let's look at resilience first. These are many issues related to resilience, and I think there's very arguably, things were very recognizable that resilience is about fire and flood and overheating and security, but actually I think that you could very easily make an argument for all of those resilience issues being health and well-being as well. buildings rotting or mold within homes, which often is a lot to do with thermal bridging details. But some of these might be peace of mind. So health and well-being mentally, slightly less tangible, possibly to measure. The sense of security somebody can have within the home, whether they're feeling safe, obviously going to be varying according to where you are within the country or what type of urban environment you are, or how you yourself feel or how frail you are. It's very different. Now, the reason why we're talking about this specifically with homes, I wanted to put this within some context, is to remind you, when I'm talking about concrete is also blockwork, okay? And actually, that's most of our homes are actually made out of concrete. So when I'm talking about this, I'm not always talking about the beautiful outhouse style, gorgeous exposed concrete interiors. We're also talking about your average run-of-the-mill cavity wall construction as well. Now, obviously, masonry and the way that that's constructed with the mass house building and the way that one might build a one-off house or possibly use precast in much larger apartments are all very different, and they're going to bring to it slightly different benefits. So I'm just going to cover the overarching benefits that all of them have in common, but that actually some of them will bring more to the fore than others. So there's a lot of reasons why masonry and concrete are used within the industry. Lots of them are to do with just the business and the cost and the supply chain and the simplicity of this stuff being around for quite a long time. But actually performance benefits is one of the key benefits of thinking about buildings over the long term. So it's the benefits of how they perform, not just while it's being built, but actually over the whole life, and how they can continue to perform in that way. And they are then therefore built in inherent both health and resilient benefits. And when it's built in, so that's that silent structure, that concrete that's often hidden, doing some really good basic stuff to help support our healthy environments internally. Now, there's a lot of brilliant exemplars for energy efficient homes built in the concrete and masonry. These happen to be all masonry ones. And I put this slide up because obviously thermal comfort in terms of keeping us warm is a pretty high up on the agenda of things that we need to be thinking about. And obviously very high up in terms of the way legislation has been going in terms of energy efficiency. And concrete and masonry can absolutely do it. It's very well established. And lots of the guidance about this is in this document, Thermal Performance, which has lots of different wall build-ups with different types of insulation and their thermal mass values, many more that are even there. And each of the different wall thicknesses according to how thick they are. Now, it's very well recognized. It's not just insulation, which is going to be bringing benefits to thermal comfort in terms of keeping us warm and making buildings low energy. So it's U values, obviously thermal bridging. We had a really great talk the other day about how you can reduce thermal bridging using concrete, and the Blockwork guys have got a whole bunch of really great free details online with pre-calculated side values for that. So you should absolutely be building best practice. Look at that free guidance. Air permeability, obviously building it tighter. We're much more concerned about that. And the thing that concrete can bring to the table then is also thermal mass. Okay, so that's all well recognized, isn't it? So I'm not really going to focus too much on that. But the point is, we also need to be thinking about what's the weather conditions going to be like in the future? Our buildings want to be sticking around for more than 20 years, 50 years, 100 years even, more than that if you look at the average age of stock. Now, don't listen to me about that, listen to the Met Office. We're meant to be designing for future climate change weather, okay? So what does that future climate change mean? And that means, if you listen to what most people are saying, it's actually going to be warmer. Must be warmer and wetter. So we're going to, so overheating. So the predicted temperatures obviously vary according to different scenarios, but we're looking at the risk from a health and safety point of view, or health and well-being point of view, is we're also coupling that with an aged population. People are possibly less able to be able to adapt and deal with overheating issues. Lots of research been going on into that. You look at the Zero Carbon Hub, did a lot of work. There's an enormous amount of research in that. I just picked out one, which is from the NHBC Trust. And what's a common thread that runs through all of that, which is why I'm talking about it, is that thermal mass is recognized. Thermal mass with ventilation is recognized as a good passive way of being able to assist with the cooling, so keeping homes cool if you've got some thermal mass in the property. So actually, if our climate is going to be like a Mediterranean climate, actually maybe our buildings need to be a little bit more akin to a Mediterranean style. But the point is to recognize is what you're saying is just all it is saying use that structure that you're going to have in there anyway, that most houses do, but make sure you're using it. So it's the mass is on the inside of the insulation. Okay, so concrete blocks and concrete itself are very high in thermal mass, higher than any lightweight. Also, maybe get a floor in as well. Now, we did a study a few years ago on overheating, but actually the whole energy efficiency of a house. We called it zero carbon house case study. It was going to be built at the BRE, didn't end up being built at the end, but it was fully detailed, and it was all the results and the details for that were published in this document. And I just put this as an example about how choices within an ordinary construction. So this was a standard detail that A2Dominion, a standard home A2Dominion produced for their social housing. And we just said, well, what tweaks can we make to make it more energy efficient? At that time, it was meeting zero carbon standards, or Code 5 as it was developing to be. But also then what were the benefits from a cooling point of view, which is why I put it in here. And so the benefit of having the thermal mass in the summer was an overall 3.2 degree reduction in the internal temperatures. So you can see what the benefit of that would be. Is in any other circumstance, maybe that might be the time that somebody's going to plug in a fan, or worst case, be putting in air conditioning. So you see the energy efficiency, but also then the natural cooling benefits that can bring as well. So another one, flooding. I mean, there's been some flood risk warnings recently, hasn't there? But it is one of the most common occurrences of disasters that we're getting, and there's a lot of predictions in terms of how our individual properties are going to be affected by this. Now, of course, it's strategic. You know, dams are looking at this from a whole community and national level to some extent are really important. But actually there is a move, and I'm sitting on this working group with DEFRA about raising awareness, property flood resilience. This was published in 2016, and the intention is that nationally we should be taking responsibility for flood resilience within our properties within 5 years. This is the aim, as much as we do for fire and security. We all put in fire alarms, we all lock our doors. We should be recognizing properly what our risk is for flooding within our own homes and designing accordingly. Okay, and that's really important. Climate change adapted figures as well. Now, the latest guidance is out at the moment is BS 85500, and the guidance within that, and the reason why we're talking about it is that it's masonry or concrete are the recommended solutions. If you're putting in something that's going to rot and warp, or it has holes in it as a frame solution would, that's not the recommended solution for something that's at flood risk. All the recommended solutions are concrete and masonry, as I said. Ideally, solid wall construction, interestingly, with insulation on the outside. Now, code of practice is being evolving. There should be a new code of practice that won't supersede this, but it'll be for all sorts of issues to do with resilience, often retrofit, that's going to be coming out at the beginning of next year. So watch out for that. But this is also the benefit, thinking about it. Floods aren't just external. I never knew this. This is called a vertical internal flood. Okay, it's basically, you know, we've all seen that. This is what my bathroom looks like at the moment, I have to say. Before I joined the concrete centre, I put in a timber floor and I've got to rip it all up from a leaking toilet. If I hadn't, you know, and that's not covered by insurance. I don't know if you know, a small drip is not an insurance claim issue. And it's the number one issue that people, actually major flood instances internal to the house. So if you've got, peace of mind, mold issues in it, there's health and well-being you can consider with that. But this is mainly, I'm talking about resilience. Resilience to fire. Obviously, it's been very high on a lot of people talking about this at the moment for very obvious reasons. I'm just going to talk about the fact that, of course, you know, there's a mental issue because people are understanding about how safe they are within their homes, and the building regs obviously cover that, although there's question marks about the building regulations. The important thing that I'm going to be talking about here, though, is that fires within homes are the number one, from a statistical point of view, it's fires within properties, and usually started within the properties, often within the kitchens is the issue. And the DCLG document, the latest one that came out, they haven't updated this since 2013-14, is that the characteristics of a building, this is what the government is saying, will significantly impact on the spread of flame and fire. Now, there's loads more coming out, obviously, about all of this, and we'll be producing stuff as and when it happens. The point is, what I'm just saying is concrete and masonry just doesn't burn. It doesn't support flames. It's inherently fire resistant, so it acts as insulation. It prevents the spread of flame. From an architect's point of view, it actually just makes detailing much simpler. And the consequences of somebody not putting in that fire stop that I've detailed is far less of an issue. So for me, actually, from a stress level and health and well-being point of view, that helps me a lot. It's long-term performance as well. The detailing is much less is much simple, but it's also less onerous. You don't need to put in as many fire stops when you're building a low rise if you're using an internal non-combustible skin. Now, the point about this I'm making is because often when we're designing our buildings, we might not know what the inside of that space is, or somebody buying a home might not know what the internal structure of their wall is, and we're saying actually you should ask. Now, moving on to some of the more health and well-being issues that are related, that are measured within the WELL standard, but also then looked at in HQM. Indoor air quality. Are you all familiar with this? A lot of it's to do with ventilation. These are some sources from that briefing paper. It's linked to allergens, asthma. It's often to do with volatile organic compounds, formaldehyde, mold, allergens, temperature, humidity, and ventilation. All of those things exasperate all the other issues above it. And the World Health Organization have recognized this, that actually the materials of a building using low emission materials are a key way of being able to reduce the exposure and your risk. This is for a slide taken from Waverton Analytics, who are people who go in and measure air quality. And this is their list of the places where these are likely to find. So it's often within glues, within paints, composite materials, naturally within timbers. There's some research into within that at the moment. So OSB, MDF, all those sorts of things. Now, the reason why I'm talking about it here within concrete is naturally inert. It supports air quality. It doesn't off-gas, there's no formaldehyde, there's no special treatments needed to concrete to make it resilient, to make it rot-proof or fireproof. It just is. Okay, so if you have to seal it, then the main thing is you need to recognize that if you're going to put sealant in, it's a no or low VOC sealant. And also it doesn't support allergens either. Now that's not a home, it's a Maggie centre, but it's the reason, these people are very vulnerable when they're visiting the Maggie centres in terms of their health, and it's the reason why that was chosen as concrete by Roger Stirk and Harbour. Noise. We all recognize how important it is to feel like you're not being, that your neighbors aren't encroaching on you, but concrete is just naturally good at damping sound, keeping the noise out. And then finally, I'm going to talk a bit about biophilic design. It's about the natural, and it's really simple, and it's actually embedded without saying that it's embedded in a lot of our design. It's about a natural link to the outside, to the daylight, to circadian rhythms, and being able and feeling less like you're in a machined, man-made environment and sort of artificial, the sort of plastics and rigid lines. And I spoke to him before I put this in the slide, Oliver, and I said, is concrete biophilic? Is there an argument there? Am I just pushing it too far? And he just said, absolutely, because it's that, and this is his words actually, natural chaotic pattern of concrete, exposed concrete, has natural variations and tonal variations in it. And actually, and that's got some benefit to it. But for me, it's about the authentic structure. It's a mineral, it's solid, and you've an instinctive understanding of the structure if it's exposed. But also, all of this is concrete. You could expose the stones, you could make some organic shapes, all of these things actually count as biophilic design. Apparently, I'm no expert in it, but I just thought I'd put that in there as well, just to sort of push the boat out a bit. So finally, that's basically the end of my presentation. We've got a summary within this document of BREEAM, of many of the issues, obviously specifically related to BREEAM, of how you can score credits within there. But it sort of summarizes many of the issues I've talked about in terms of the benefits concrete can bring. And that's a summary of all the resilience benefits of concrete. Thank you very much.